local linearity, tangential surface, gradient vector, partial derivative, so many things. Can someone really remember this? That this way, this is the place that I have to do partial derivative. This is the place I have to do tangential equation. This is the place tangential surface. This is the place gradient vector, and uh, this is the place that I have to do some other things. So, so many terminal. Is it really possible that someone would kind of remember local linearity, approximation in linearity, chain rule? Chain rule, you are awesome, you are amazing. So if you know a chain rule, then you don't need to remember anything. So that is the concept. So we'll see one by one. I mean, in a sense that right now we'll see how we can apply chain rule while calculating the directional derivative. If I want df, I have okay, so I have two axes. So this is x-axis and this is y-axis. X-axis, y-axis. This is xy plane. So if this is xy plane, then vertical direction is fxy. If vertical direction is fxy, function over two independent orthogonal independent variable fxy. If that is true, then how much the vertical component, that is z. So how much now in the xy plane, this is x-axis, this is y-axis, this is any vector. X-axis means unit vector I, y-axis is unit vector j, and any axis is unit vector or vector u. So this is vertical is z, function over x and y, fxy. How much z varies if there is a unit variation? So there is a surface equation fxy equal to something like 1 minus x square minus y square to the square root. So this is the equation of a sphere. So if there is a unit variation along x-axis, there is a unit variation along y-axis, then how much there is a variation along z-axis. So if there is a unit variation along x-axis, then y is constant. If there is a unit variation along y-axis, then x is constant. So how much z would change if there is a unit variation along x-axis and unit variation along y? How much there is a one unit variation along any vector u? Then how much function over xy, fxy or z would vary? Now I have to see local linearity and then partial derivative and so many things. Okay? Chain rule, you're awesome, you are amazing. So consider how vectors are formed. If I have a vector called 2i, okay, 2i is moving along positive I direction, 3j moving along positive y direction, and 4k moving along positive z direction. If that is true, then x-axis, y-axis and z-axis, if three vectors they meet at origin, then they take one resultant direction. So that is 2i plus 3j plus 4k. So that is, if I have a vector 2i plus 3j plus 4k, means it is addition of three vectors. Three vector would have met at origin, coming from negative x-axis going toward positive x-axis, coming from negative y-axis going toward positive y-axis, and coming from negative z-axis going towards positive. If they three met at origin, the resultant vector is 2I plus 3j plus 4k. If there is a variation in the x vector, then resultant vector would vary. So 2I plus 3j plus 4k has magnitude and direction. So direction we know, magnitude is 2 square plus 3 square plus 4 square square root. If x direction vector is changing, then certainly it would change. If there is a variation in the resultant vector, it is 2I plus 3j plus 4k. So net is 2 square, 3 square, 4 square, square root. 16 plus 9 plus 4. So it will come as 29 square root. So instead of 29 square root, it is 39 square root. Then all the x and y and z component would vary. So if the net vector is varying, then its components would vary, or one of the component vary, then net vector is varying. So dx by du is true, then du by dx is also true. Now, if we have a function over x and y, fxy, then dfxy by dx means, so fxy has two components, along the x-axis, along the y-axis. And based upon these two components on the xy plane, fxy changes. So z vertical changes. So if I have xy plane, whatever xy point we take along the plane, as per the point, then its vertical point z would change. So fxy changes. Now dfxy dx means if there is a variation along x-axis of unit variation along x-axis keeping y constant, then it's also called partial derivative. Then how much fx changes? So dfx by dx. If there is a small 1 unit change along y direction, then how much fx would change? If there is a unit change along u vector, then how much fx would change? So that is the question. Directional derivative in calculus through chain rule. So this is the topic. So through chain rule, without bothering about partial derivative, local linearity, and so many other stuff. Okay, so partial derivative, local linearity, tangential surface, tangential vector, and then gradient vector, then dot product of gradient vector and any vector u, so many ux, uy. Okay, so if we go for chain rule, then we don't need to remember anything. So directional derivative through chain rule. So that is the concept. dfxy d dfxy by du. How how much z, that is function over xy, would vary if there is a unit variation along u vector. If this is I vector, this is j vector, this is k vector, if this is u vector, then if there is a unit vector change along u vector, then how many units of change we see along the z axis? But z is not dependent upon u. Z is fxy, function over xy, where where it only changes when there is a change along x-axis and y-axis. How much it is? So change along 1 unit of change along axis, how many unit of z it brings the change, plus 1 unit of change along y-axis, how many unit of change it brings along z-axis. If we add these two components, because they are orthogonal, as we said, that orthogonal components, they always always add something. If two people are not related to each other, they don't know each other, if you bring them to work, they will never talk. So you get the maximum work. Well, they are orthogonal to each other. But if you bring two friends or two relatives in the work, then certainly they will keep talking about their village or relatives and all. So orthogonal component, they always bring maximum what we get. So dfxy, change dfxy means change in fxy if there is a delta if I want to calculate, then I have to calculate how much fxy means z would change if there is a unit variation along x-axis plus there is a unit variation along y-axis. So unit variation along x-axis brings how much unit of variation along z-axis, and unit variation along y-axis brings how much unit variation along z-axis. So dfxy dx and dfxy dy. If we know these two, then if we add, then we get delta z. So delta z, or in other term, we can say partial derivative of along x-axis and partial derivative along y-axis. If we add, but in chain rule, dfxy dx, dfx dfx or delta fx, how much delta in fx is seen, then that is delta fx by dx plus delta fx by dy. Through x how much it is changing, and through change in y, through change in x how much it is changing, plus through change in y how much it is changing, then we can add. But what we want is dfx dfxy by du. If there is a, this is I vector, this is j vector, this is u vector, along the u vector if there is a unit variation, then how many unit of variation we see in z-axis. So in along the u vector, if I take 2 points and distance between these 2 points is 1 unit, then as these 2 points, what is z? Then if I differentiate, how much we get. So this is what we want. But problem is fxy we know. Okay, function over u that gives the z we don't know. But function over, okay, so if I have a unit vector, then it has, any vector has is combination of three vectors or two vectors or one vector. If it is three dimensional, it was combination addition of a vector that was moving along x-axis, y-axis and z-axis. This is what we have seen. If so, if I have a vector u that is a combination of two vectors x and y, then one vector was moving along positive axis or positive direction in x-axis, and one vector was moving along positive direction along y-axis. If they combine each other, then it forms vector u. So vector u has x component and y component. This is what we can say. Now, if there is a change in vector u, then there is certainly change can be seen along x-axis and y-axis. So dx by du is there. If there is change in u, then there is change in its x component. If there is change in u, then it brings change in y component. Dx by du, dy by du. Okay, or du by dx, du by dy. If there is change in only x component, also brings change in u. Now we want dfxy by du. Okay, that is equal to dfxy by dx, dfx by dx into dx by du. This is chain rule. So if I want only delta fxy, then it is dfxy by dx plus dfxy by dy. Change of one unit vector along x-axis bring how much change along z-axis, plus change in one unit vector brings how much change along z-axis. If we add both, then it is delta fxy. If you want delta fxy by delta u, then delta fxy by delta x we know, and so fxy's variation through x we know, and x variation through u we know. If we change the vector, then how much is x component we know. So we know dfxy by dx, we know dx by du, we know dfx by dy, then we know dy by du. So dfxy by du equal to dfxy by dx into dx by du. If we do cutting of the diagonal, then it comes to dfx by du. So dfxy by dx into dx by du plus dfx by dy into dy by du. This is chain rule. No need to remember partial derivative, tangential surface, tangential vector, gradient vector, local linearity, approximate linearity. and then contour and then sharp variation of this function, that nothing. Dfx by du. Fxy function over xy does not depend upon u, but u depend upon x depend upon u. If we have kind of, so chain rule can be said as recursive rule. It is recursive in nature. It's not only chain, but inside the chain, if there is another chain, then it will go through. So by du, or delta in fx with respect to delta in u, is equal to delta in fxy plus delta x into delta x by d delta u, plus delta in, because it has two components, f has two components, delta fxy by delta u, delta y into delta y by delta u. This is chain rule. So dfxy by du equal to dfxy by dx into dx by du plus dfxy by dy into dy by du. U vector also dependent upon time. If time varies, then u vector also varies. It becomes long, short, changes the direction. What is dfxy by dt? If x has variation, if fxy has variation because of x, and x has variation because of u, and u has variation because of t. If t varies, then u varies. If u varies, then x varies. If x varies, then fxy varies. What is dfxy by dt? Was through gradient vector and tangential surface and local linearity, you cannot get. What if t is dependent upon wind speed? Then what is dfxy by d wind speed? This is amazing. Chain rule, you are amazing. Dfx by dt equal to dfxy by dx, dx by du, du by dt plus dfx by dy, dy by du, du by dt. Suppose that u is kind of u is a function of t and x, t and r, rather than u is function of so dfx by dx into dx by du, and now du is function of t and r, so into du by d dx by du, and in braces du by dt plus du by dx. Chain rule is recursive. Wherever it is variant for multivariable case, you have to add multivariable case differentiation. Then again start the chain rule. Chain rule, you are amazing, you are different. I mean, you have to kind of appreciate our invention. So whatever the chain rule we have brought in for the components, so dfxy by change in dfx. So delta fxy is nothing but delta fxy by delta x plus delta fxy by delta y. All its component unit vector change, how much it comes, then we have to add. If we know this, then delta fxy by delta u, or delta fxy by delta t equal to delta fxy by delta x into delta x by delta u into delta u by delta t plus delta fxy by delta y into delta y by delta u into delta u by delta t. If u is component, if u is variation with two independent variable t and r, then delta fxy by kind of any of the component if we take, then it will go along. Or delta fx by fxy, if we say only t, delta fxy by delta t, then delta f dfxy by dx by du and du by dt. Okay, suppose t and r down the line, they both are dependent with something like alpha. The dfx by dlf alpha will go with the t and r along, and then alpha. I mean, you can write and you can try. So Chain rule is nothing but recursive rule. Wherever we have multiple variables, then you have to add the way dfx was dfx by dx plus dfx by y by dy. So if it is multivariable, you have to add and then proceed. Singular variable, only singular. So, can you try? I mean, I would also try. So, since this is an invention, so we are trying. So, if during the chain, if we find that somewhere we get multivariable dependency, then how we will go along? But dfx by dt equal to dfx by dx into dx by du into du by dt plus dfx by dy, dy by du and du by dt. We can keep doing. Try with multivariate anywhere in the chain where any point it is multivariate. Then keep doing. Chain rule, you you allowed me to forget everything. Okay? Past is bright, present is bright, future is bright. Okay? Take pen and paper and start.